Welcome to this video. In this video, we're going to look at how to take a derivative of a polynomial function. A definition. First, a polynomial function is a function that contains sums and differences of terms in the form a times x to the power n. Here, the coefficient a can be any real number, and n is a non-negative integer. Examples of polynomial functions include 3x cubed minus 5x squared plus x plus 15, x plus 1, or x raised to the power 10. The polynomial differentiation formula is based on the expression in the form a times x to the power n. The first thing that we're going to do is take the power n and multiply it by the coefficient a. Our next step is going to be to then subtract 1 from the power n, which will give the formula n times a times x raised to the power n minus 1. This formula can be applied to any polynomial term. All right, example number 1. Let's find the derivative of 3x raised to the power 7. The first thing that we're going to do is multiply 7 by 3. And then we will subtract 1 from 7, which will give us an answer of 21x to the power 6. I would like to point out here that this problem uses Leibniz notation, and so the problem statement already indicates the derivative. So the notation is fine, and the steps can be shown just as they are here. For example number 2, we're going to find the derivative of a function f of x that is equal to x to the power 4 divided by 2. To make things a little bit easier, I'm first going to just rewrite this function as 1/2 times x raised to the power 4. It helps to be really clear and be able to see that 1/2 is the coefficient and 4 is the power. So the derivative will be equal to, we're going to multiply 4 by 1/2 and then subtract 1 off of 4, which will give 2x cubed. Again, I would like to point out that this problem is slightly different than the last in terms of notation. In this problem, we used function notation. All right, so for function notation, you must actually then indicate that your answer is the derivative. So that is, it's not the same function as the original function f of x. And we do that by using the f prime notation. A common error here is to say that if a function f of x is equal to x to the power 4 over 2, then the derivative is equal to 2x cubed without that additional indication that this is now a different function. So the statement that is given here is actually not true. Example number 3. Let's find the derivative of f of x equals x squared minus 6x plus 2. So any terms that are separated by a plus or a minus can each be handled individually. We can take the derivative of each term by itself. So again here, just for clarification, I'm going to rewrite the function as x to the power 2 minus 6x to the power 1 plus 2x raised to the power 0. All right, so when we have just x, we don't typically write that power 1, but I'm going to indicate it here just to help with this power rule. And then a constant 2 can be written as 2x to the power 0. So the derivative f prime of x will be equal to, right? So just by applying our rule, we will multiply 2 by the coefficient of x, which is 1. So that becomes 2x raised to the power 2 minus 1. Subtract 1 from the power. For the next term, 6x to the power 1, if I take the derivative, it'll become 1 times 6 times x to the power 1 minus 1. And then for the final term, 2x to the power 0, we will multiply 0 by 2, and then again subtract 1 off of the power. We're going to clean up this answer. We will get that this is equal to 2x to the power 1 minus 6x to the power 0 plus 0 times x to the power negative 1. And I will include one more step of simplification. This gives us a final answer of 2x minus 6.